and welcome to Math 1300. This is a course through Nunez College, and I am going to be going over each one of the sections that's in the book that is your homework. The first section that we're doing is section 6.1. This section is Introduction to Equations. Now, an equation is anything that's got an equal sign. So if we have x plus 2, but there is no equal sign, then this is called an expression. The moment, though, that we put an equal sign in and equal it to something, then it's called an equation. So we are going to be working with equations. Examples would be like 9 plus 3 equals 12. That's an example of an equation. Y squared plus 4y equals 25 would be an equation. And what we want to do is we're going to end up solving these equations. Now, the first thing I want to do is I want to find if an answer given to us is a solution to the equation. In order for a solution to be correct, the two sides of the equal sign must be the same. So the first one says, is 2 a solution of 2x plus 5 equals x squared minus 3? So let's go ahead and write the equation given to us, which is 2x plus 5 equals x squared minus 3. They want to know, is 2 negative 2 a solution? Is negative 2 a solution? In order to figure that out, we're going to plug in negative 2 everywhere we have x's and see if the numbers on either side are then equal to each other. So I'll have 2 times negative 2 plus 5 equals negative 2 squared. Notice it's negative 2, so we put negative 2 in parentheses because that is what's squared, minus 3. If I go to the next step, I have what? Negative 4 plus 5 equals negative 2 squared means negative 2 times negative 2. It means this 2 times. And negative 2 times negative 2 is positive 4 minus 3, giving us what? Negative 4 and 5 gives me 1 equals negative 4 plus 3 equals 1. This indeed checks out, so negative 2 is a solution to that problem. That's what they want to do for the first part. They just want to find out if we plug the numbers they're asking in to the equation itself, is the equation going to be equal on both sides? Now, when solving for equations, we're going to actually find the value of the variables. Variables are written with letters. Most of the time, pretty much all the time, the letter I'm going to use is the letter X. And in order to solve, we want to end up with x by itself equals some number. And by some number, 2, 3, 5, some number that we're looking for. So that's our objective. X equals some number. We don't stop until we get there. Now, in order to achieve that, we do the opposite of what we see in order to get things away from the x. So in our first question, example, well, this is our second, example number 2, I have x minus 4 equals 2. X minus 4 equals 2. And I'm trying to solve for x. So again, I want to get x by itself. X is on the left-hand side of the equal sign. The 4 is what I want to get to the other side. So in order to get this negative 4 to the other side, I'm going to do the opposite of what I see. This is x minus 4. When you were in school, you learned the opposite of subtract is plus. So I'm going to take this and I'm going to then add 4. But if I add 4 to the left-hand side of this equal sign, I must add 4 to the right-hand side because I got to keep everything even. If I subtract 4 and add 4, these both go away. X now is by itself. Over here on the right, I have 2 plus 4, which is 6. X equals 6. This is solving an equation. X by itself equals the number. Now, when doing this, we're going to come up with all kinds of steps that we have to take But each step that we're going to do is going to be just like we did here. It's the opposite of what you see to bring it away from from the side of the variable. So if I have 3 equals 5x minus 2, now we have more steps in which to do what we have to do. Our x is on the right-hand side of the equal sign this time, but I have 2 numbers to take away. I have 2 numbers to take away. And what do we have here? This says minus 2, so that's a subtraction. And this is 5x. 5x means 5 times x. So what we're going to do first is we're going to take away what we learned first in school, which is the addition and subtraction. So minus 2, we're going to add 2 to the right. But if I add 2 to the right, I'm going to add 2 to the left. So these 2's would go away. I would have 3 plus 2 is 5. Bring down my equal sign, and I would have 5x. So we accomplished taking away one of the 2 numbers. Now our goal is to take away the second one so that we can have x by itself equals the number. This says 5 times x. In order to do it, we need to do the opposite. The opposite of multiply is divide. So I'm going to divide by 5, divide by 5. They would cancel out, leaving me x, and 5 over 5 is 1. X equals 1 is the answer. If x is on the right-hand side of the equation or on the left-hand side of the equation, it's the same thing. So this would be equal to x equals 1. Both of them would be the same thing. Whether you prefer to have it on the left or on the right. Most of the time, I like to have the variable on the left, but it does not really matter. It does not really matter. So, for the next one, suppose we have more than one variable on one side of the equation. Suppose I have 5x minus 9x equals 12. Well, our goal is the same thing all the time. We have to find x equals a number. Since I have 2 of them here, I'm going to do something called combine the like terms. Since these are both the same thing, I can combine them. So I have 5x minus 9x gives me negative 4x, equals doesn't go anywhere, bring the 12 down. I went from 2 variables here down to 1 by combining them. Now everything continues to run the same. This is negative 4 times x. I need to get rid of it, so I'm going to do the opposite. Opposite of multiply is divide, so I'm going to divide by negative 4, divide by negative 4. These cancel along with the negatives, and I got x equals negative 3. This would be our solution. That would be my solution. Okay, next one up, we are going to have another operation to fulfill. We're going to have 3 times x plus 2 in parentheses minus 5x plus 2. This equation here, just like the one that we had a second ago where we had to combine our x's by combining like terms, this one here, according to the order of operations, please excuse my dear Aunt Sally, the parentheses, exponents, multiplication, division, that what we learned a while back. We have here a distributing situation. This 3 needs to be distributed to both of these terms in the binomial, which means the 3 multiplies by the x and the 3 multiplies by the 2. This would give me 3x plus 3 times 2 is 6 equals 5x plus 2. Now we have x's on both sides of the equal sign, an x on the left and an x on the right. So I can't just combine them the way that we did with the last one. With this one here, I need to bring the x's to one side or the other. And as I said, it doesn't matter whether the x is on the left or on the right. My goal here is I'm trying not to mess up. And if I need to divide or multiply, I would rather do it with a positive number rather than a negative. So because of that, I'm going to always take the smaller x and bring it to the larger x. because when I do that, it stays positive, and that's what I'm trying to do. So I'm going to pick a side. I'm picking to bring it to the right because that's going to be bringing it to the larger x. So I'm going to subtract 3x here, subtract 3x here. That goes away. I have 6 equals 5x minus 3x is 2x plus 2. Now my x is on the right. I have two things in order to get rid of to bring it to the left. The first thing I'm going to do is to add and subtract. In order to get rid of the plus 2, I'm going to subtract 2 from both sides, canceling it out. 4 equals 2x. Now I have multiplied. Opposite of multiplication is division. Divide by 2, and x equals 4 divided by 2, or 2. Again, my habit is to put the x on the left, but again, like I said before, x equals 2 or 2 equals x is the same thing. Okay, on to example number 6, I think it is. We only have a couple of examples left. This one is if I have a fraction multiplied by my variable. There's an easy little simple way of dealing with this. If I have 3/4 x equals 9, 3/4 x equals 9, a lot of times we look at the fraction and we get nervous, we freak out. Well, if this is our case, I want to multiply, but I want to multiply by this thing here, the reciprocal of it. Reciprocal means flip. So if I flip this, it becomes 4/3. So I want to multiply by 4/3. But if I multiply it by 4/3 here, I multiply it by 4/3 here. What does multiplying it by 4/3 do? Well, it allows me to have a 3 on both the top and the bottom, which I can cancel, and a 4 on the top and the bottom, which I can cancel. So by flipping and multiplying, I take this fraction and I eliminate it. It's just leaving me with x. And when multiplying on the other side, we multiply fractions straight across. So 9 means 9/1. 9/1. So I can multiply straight across, giving me 36/3. 36/3. And then I would simplify it because 36 divided by 3 is 12. Or I can say, since I'm multiplying, just like here where I canceled the 3's and I canceled the 4's, I could say that 9 divided by 3 is 3. So I could cancel the 3 and the 9, making that a 3. And 3 times 4 would give me 12. This way is fine, or multiply straight across and then simplify the final fraction to what we have. Simplify the final fraction to what we have. Either way, we come up with x equals 12. Remember, multiply by the reciprocal if you have a fraction with your variable. All right, on to example number 7, I think it is, and this will be the last example for this section. This one here deals with fractions, straight up fractions. Suppose I have x plus 3/4 equals 1/2. X plus 3/4 equals 1/2. I'm a math teacher, and I don't like fractions. I know most of y'all don't like fractions. So what we're going to do here is, the first thing we want to look at is, can I possibly get rid of the fractions? And pretty much most of the problems that we work with, getting rid of the fractions will be the easiest thing to do. In order to get rid of a fraction, I want to multiply by something called the least common denominator. The least common denominator. So the least common denominator is going to be the smallest number that all these denominators go into evenly. So the numbers we're looking for is a 4 and a 2, and x is over 1, so a 1. But a 1 kind of doesn't change anything, so we're only worried about the 4 and the 2. So what would be the smallest number that both 4 and 2 go into evenly? That number would be 4. So 4 would be my least common denominator. 4 goes into 4 and 2 goes into 4 evenly. So 4 would be my least common denominator. So since that's my least common denominator, I'm going to multiply that number 4 by all 3 terms. And if I do, I'm actually going to get rid of the fractions throughout the whole problem. So I'm going to multiply the 4 times the x, I'm going to multiply the 4 times the 3/4, and I'm going to multiply the 4 times the 1/2. Now, if I multiply 4 times x, that's 4x. As we did on the last problem, this is what? Multiply, so I can cancel. Cancel the 4's, I'm left with what? A 3. And then on this side, I what? Can cancel a 4 and a 2. 2 goes into 4 2 times. 2 times 1 is 2. What I did though, is by multiplying by 4, I made the whole problem 4 times larger. I got rid of the fractions. And I would much, much, much rather deal with this than to deal with subtracting 3/4 and trying to deal with fractions. So now, once I get to this is an easy problem. I got what? 4x, I'm subtracting my 3, so I got what? -1. Divide by 4, and I come up with x equals -1/4. X equals -1/4. But again, if you have a fraction problem, try to find the LCD. If you can find the LCD, multiply by that number, and you'll get rid of your fractions. All right, well, thank you. This concludes section 6.1. I'll be doing all the rest of the sections. You'll be able to find it on YouTube. I hope it helps out when you're doing your work.